Welcome to the Microsoft Backend Developer Professional Certificate. Think about your favorite app, whether you're streaming videos, ordering food, or managing your finances. Everything seems to work flawlessly in the background. But how do these apps handle millions of users interacting all at once? That's where backend development comes in. In this program, you'll learn to build and manage the systems that make these seamless experiences possible. Across 8 comprehensive courses, you'll gain the foundational skills, advanced techniques, and use cutting-edge tools like generative AI that will set you apart as a backend developer. Let's explore the courses in this program. We'll begin with the foundations of backend coding, focusing on key principles and practices. You'll learn to plan and structure projects using tools like Microsoft Copilot for efficient coding and debugging. You'll practice logical thinking and problem solving to design algorithms and flowcharts to represent the flow of programming tasks. You'll also implement control structures and loops for efficient execution. By the end, you'll be able to develop modular, reusable code for more complex projects. The next course is Introduction to Programming of C#. In this course, you'll dive into C# to set up and configure .NET projects in Visual Studio Code. You'll learn key programming concepts like variables, control structures, loops, and methods, and apply object-oriented principles like classes and inheritance to build scalable applications. You'll also develop asynchronous programs and use debugging techniques to ensure performance. With Microsoft Copilot, you'll efficiently write, debug, and optimize your C# code. Building on your C# skills, we'll move into backend development with .NET. This course offers an in-depth look at the .NET framework, covering the differences between .NET Core and .NET Framework, common libraries, and setting up a development environment. You'll create a simple web API using ASP.NET Core, integrate Open API for documentation, and learn C# syntax in the context of .NET. With Microsoft Copilot, you'll efficiently write, debug, and implement API code and middleware for seamless backend service development. The next course is Database Integration and Management. This course offers a comprehensive introduction to relational databases using Entity Framework Core, also known as EF Core. You'll learn to set up databases, model data, and retrieve and manipulate it with SQL. The course covers SQL syntax, advanced queries, performance tuning, and security best practices. You'll also manage transactions and ensure data integrity while using Microsoft Copilot to write, debug, and optimize SQL queries for improved performance. The next course focuses on one of the most critical aspects of backend development, security and authentication. You'll learn how to secure applications with ASP.NET Identity and role-based access control. You'll cover user registration, token-based authentication, encryption, and the use of JSON Web Tokens, also known as JWTs. Using Microsoft Copilot, you'll write secure code, implement authentication and authorization, and resolve security issues to protect users and data. Once your systems are secure, it's time to ensure they perform at their best. In the Performance Optimization and Scalability course, you'll learn how to fine-tune your applications for speed and efficiency. You'll learn the importance of caching, query optimization, and key principles of scalability. You'll also explore techniques for analyzing query performance, managing traffic with load balancing, and following best practices for caching and query optimization. With the help of Microsoft Copilot, you'll optimize code and database queries to handle increased traffic efficiently. To take your optimization even further, in the Data Structures and Algorithms course, you'll learn how to analyze and choose the right data structures, like arrays, linked lists, and trees, as well as sorting and searching algorithms to make your code more efficient. Using .NET, you'll implement these techniques to solve backend problems, focusing on performance and scalability. Throughout this course, you'll design backend applications that handle large amounts of data smoothly and optimize your code to run faster and more efficiently. And finally, with all the foundational skills in place, you'll learn how to put your applications into production. The Deployment and DevOps course teaches you to deploy and manage backend systems using Azure Cloud Services. You'll explore Azure's features, secure applications, and monitor performance. The course covers preparing apps for deployment, scaling, and automating tasks, along with continuous integration and continuous deployment known as CI/CD. With Microsoft Copilot, you'll develop deployment scripts, CI/CD pipelines, and optimize deployments for seamless application delivery. By the end of this program, you'll have mastered the core skills of backend development: database management, API integration, security, scalability, and more. With these tools, you'll be ready to tackle real-world challenges and build the systems that power today's digital world. You'll also develop expertise in optimizing performance and deploying applications with confidence. The integration of generative AI tools throughout the course will equip you with cutting-edge techniques to stay ahead of this rapidly evolving field. We're excited to guide you on this journey and can't wait to get started. Welcome to the Foundations of Coding Backend course. Here, you'll master essential backend development skills, from version control with Git and GitHub to advanced C# programming. This course is designed to enhance your ability to develop efficient, robust software, preparing you for complex challenges in software development. We will begin this course by defining the principles of backend development, outlining essential steps for project planning, and identifying key development tasks. We will also cover project planning integration with development tools and introduce the basics of using Git and GitHub for version control, setting a strong foundation for efficient backend development. Next, we will explore the critical role of logical thinking in programming, applying deductive reasoning to break down complex problems into manageable parts. We will discuss strategies like top-down and bottom-up approaches and practice writing pseudocode, enhancing your problem-solving skills in real-world scenarios. Then, we will focus on the structure of algorithms and the use of flowcharts to visualize logical steps, crucial for effective programming. We will examine various data types in C# and implement simple algorithms, reinforcing your understanding of declaring variables and manipulating data effectively. Next, we will explore control structures and loops, defining if-else statements, switch cases, and various loop types to handle decision-making and repetitive tasks. Through small coding exercises, we will combine these elements to build simple yet powerful programs, boosting your coding fluency. Then, we will examine the use of functions and methods in C#, discussing their definitions, syntax, and practical use cases. We will practice calling methods, passing data with parameters, and developing programs using these constructs, aiming to enhance your ability to write reusable and efficient code blocks. Finally, we will explore utilizing Microsoft Copilot for writing and debugging C# code. We will demonstrate how Copilot can help you write cleaner code, debug effectively, and improve code quality and efficiency, preparing you to apply these skills in your C# programming projects. By the end of this course, you will be prepared to tackle complex development challenges, create efficient software, and sharpen your problem-solving abilities. We're excited to support your journey to becoming a skilled backend developer, ready to apply advanced tools in real-world projects. Hello, my name is Tyler Morgan, and I am one of your instructors for this course. I've been a developer since 2011 when I started writing my first applications. However, my journey with programming began much earlier. I first tried to learn programming back in 1999 when I was in the 7th grade because I wanted to build a video game. I eagerly picked up books and tried to learn on my own, but I failed miserably at even grasping the basics. The main reason was that I didn't have anyone to guide me and show me what I needed to do. This experience scarred me so much that I didn't attempt programming again until I was in college when I was required to take an introductory programming course. In that course, I finally learned the very basics of programming. It gave me the confidence to believe that programming was something that I could tackle. The problem was that while I understood the syntax of programming, I still didn't know how to turn if statements and for loops into software. It wasn't until I discovered online courses that my abilities as a developer really took off. These courses held my hand a little bit, showing me what I needed to learn and steering me away from topics that were too advanced for my experience level. Thanks to the help of these courses, I began to understand how the web worked, how to build software, and how to turn the things in my imagination into reality. I was so enamored with online learning that I went to work for an online education company, building their alumni network. That work gave me the confidence to break out on my own as a software developer. I started a company called Numerite, where I did cutting-edge web-based visualization work for the federal government and groundbreaking machine learning for university researchers. And I created awesome tools for huge companies. Then a few years ago, I had the opportunity to fulfill my dream of starting a farm. Now you might think farming has very little to do with software engineering, but it's amazing how handy it is. I wrote my own software to manage crop planning, built our website, and integrated with external services to create the functionalities that my customers wanted. I created entire data pipelines to ingest local market data and determine where there were gaps in local agricultural production. I'm sharing all of this with you because learning how to be a developer isn't just for those who want to work for big tech companies. It's an amazing tool for anyone. And with proper guidance, you can learn what took me decades in just a few months. So let's get started.
The learning experience in this course is designed to give you a comprehensive understanding of key concepts through various learning methods. You'll be guided through interactive, engaging materials that help you build practical and theoretical knowledge. Whether you're interested in front-end, back-end, or full-stack development, this program has the tools to support your growth every step of the way. Throughout the course, you'll be introduced to core concepts and key ideas in videos. These videos are designed to help you understand definitions, processes, and essential steps clearly and concisely. You'll get to absorb foundational knowledge, setting the stage for deeper exploration as you move forward. And when you need step-by-step guidance, screencasts will provide you with a detailed practical view. These screencasts will show you exactly what's on the screen and how to work through specific coding tasks. The course also includes readings that reinforce the key ideas presented in the videos. These readings are more than just supplementary material, they're job aids. You can print them out and use them as a reference while working on assignments or activities, helping to apply what you've learned in real-world situations more easily. Small activities are included to help you check your understanding of key ideas. These activities provide quick, interactive opportunities to practice what you've just learned. After completing each activity, you can compare your work with a fully explained example and answer key. This ensures that you always know if your answer is correct. Practical experience doing tasks you would in a job within this field is essential, and that's where guided labs come in. These labs take you through the implementation of different concepts step by step. As you work, you'll receive feedback and helpful hints, ensuring you can get the help you need when you need it. It's the perfect opportunity to practice in a controlled environment while learning by doing. After completing the guided labs, you'll move on to independent projects, or you try it. This is where you'll put your skills to the test, applying what you've learned in the labs. You'll work through real-world problems, cementing your understanding of the course material. The course will culminate in a practical project leveraging Microsoft Copilot that you can use as a portfolio artifact when you begin your job search in this field. As you progress through the program, the portfolio pieces will become stronger and better representations of the authentic experience you've gained. They'll showcase your understanding of code and the ability to implement different concepts from the developer program. This course guides you step by step from understanding concepts through videos and readings to apply them in activities, screencasts, and labs. Each part of the course builds on the last, helping you gain knowledge and authentic experience. By the end, you'll have completed real projects that not only showcase your skills, but can also be included in your portfolio as you start your career. Everything you do here will prepare you for success as a developer. Let's get started.
Throughout this course, you'll complete several guided labs. These labs are meant to give you an opportunity to practice your newly learned skills in an environment where you can get help and feedback as you complete coding challenges. This video will describe how to complete the guided labs in this course. We will explore a guided lab together so that you'll know what to expect when you come to one later in the course. First, let's check the content leading up to a guided lab. This structured content ensures that you have exactly the skills you need to complete the task. In this instance, there is a practical application video that describes in detail how this concept is used in real-world situations. Following this practical application video, you can review a reading that explains the concept in detail so you can go through this content at your own pace. Next, you'll find a video that works through the guided lab itself. This video won't give you all the answers to the guided lab, but it will provide an overview of the upcoming questions and challenges. Lastly, we come to the guided lab itself. The guided lab is a simulated code environment where you can experiment with code and receive hints and feedback in a realistic coding situation. To start, I'll click Start. In this lab, step 1 is an introduction to if-else statements, so I'll click Begin. Below the simulated code environment, I can find the specific instructions for this lab. Declare the variable age as type int. Place your cursor into line 2, type your answer, and select Enter to check your work. Alright, I think I know this one. I'm going to type in INT and hit enter. Great, I got that correct, and I got a bit of feedback about my correct answer. To move on, I click continue. And these instructions say, prompt the user to enter their age, place your cursor into line 4, type your answer, and select enter to check your work. This one is a little trickier. Let me try type your age. Got it. This feedback for my wrong answer points me in the right direction. Let's try that again. I'm going to erase what I had here and then enter your age. Perfect. I'll click continue. Let's try one more. Convert the input to an integer using int.parse and store it in the age variable. Place your cursor into line 6, type your answer, and select enter to check your work. I'm not totally sure here, so I'm going to click on hint and get some help. And the hint says use console.readline, and then an open and close parentheses, display a message asking their user for their age. Great, that helps. I'm going to click continue and type in console.readline. And I've got it. That's how you work through a guided lab. Some questions will require more complex code to complete, so make sure you're using the hint function when you need it and reviewing the feedback provided for your right and wrong answers. Have fun completing these coding challenges that put your new skills to work.
In today's rapidly evolving tech landscape, artificial intelligence plays a key role in making development more efficient and intelligent. That's where Microsoft Copilot comes in. Microsoft Copilot is a powerful AI-driven tool that can assist developers in writing, optimizing, and debugging code. In this course, you'll leverage Copilot as a thought partner and a code-generating assistant, helping you solve problems, generate code snippets, and enhance your projects. The goal is to provide you with hands-on experience using a tool that real-world developers use to improve their workflow. In the last module of this course, you'll engage in videos, screencasts, guided labs, and independent projects that integrate Copilot. These labs will take you through how to use specific prompts to generate code, optimize solutions, and solve problems. You'll be shown step-by-step how to leverage Copilot's capabilities to strategically approach the final project. During the guided labs, you'll get hands-on experience working with Copilot. These labs are structured to show you how to craft effective prompts and work with Copilot's code generation features. You'll use it to assist in writing code, refining your solutions, and debugging. This practice will prepare you for the independent work you'll do in the final project. After the videos, screencasts, or guided labs, you'll move on to independent activities where you'll take control. Here you'll use Copilot to assist with various aspects of the project. You'll be making strategic decisions, but Copilot will support you by generating code, suggesting optimizations, and helping you troubleshoot. This prepares you to work more independently while still having the power of AI to assist. The final project will combine everything you've learned in the course, and you'll have Copilot as a key tool in your development toolkit. You'll use Copilot to help you generate and refine code as you combine the concepts from earlier lessons. The project is a portfolio-ready artifact showcasing your coding skills and your ability to leverage AI in modern development workflows. To succeed in the final module, actively engage with the guided labs and practice using Microsoft Copilot effectively. The videos and prompts will take you through Copilot and equip you to apply it strategically and independently. By the end of the course, you'll be fully prepared to complete the final project and demonstrate your skills using traditional coding and AI-assisted workflows. Welcome to the course. In this video, we will discuss how you can make the most of each part of the course to set yourself up for success. Whether you watch the videos, complete activities, or work through hands-on labs, each element has been designed to help you master the skills you need to become a confident and capable developer. The first step in every lesson is the videos. You'll be introduced to new concepts, definitions, and key ideas. Watch these carefully and take notes on the important points. The videos provide the foundational knowledge you'll need to build on, so don't skip them. They'll give you the context to understand everything that comes next. After each video, complete the readings. These readings reinforce the key ideas you've just learned and can serve as job aids. I recommend printing out the readings or saving them for quick reference. They'll be extremely helpful when completing activities, working on projects, or just needing a refresher. They're not just supplementary. They help you apply what you've learned to real-world tasks. Throughout the course, you'll find small but impactful activities. These quick exercises allow you to check your understanding of key ideas. Don't rush through them. Take the time to work through these activities thoughtfully. After each, compare answers with the answer key to check how well you understand the material. This is your chance to practice without pressure. At the end of each lesson, you'll encounter practice quizzes. These quizzes are a great way to ensure you fully grasp the concepts from the videos and the readings. Use these as a checkpoint to assess how well you retain the information. If you find yourself struggling, review the videos and readings again. The goal is to build confidence and solidify your understanding before moving forward. When you need to see the material in action, screencasts guide you. These videos show you exactly how to work through certain tasks step by step. If you ever feel stuck or unsure about applying a concept, watch the screencasts and follow along. This hands-on guidance is invaluable for understanding how the code works in real time and applying what you've learned. At the end of each module, there will be graded quizzes. These are an important part of your success as they allow you to demonstrate mastery of the material. These quizzes build on the practice quizzes, and they're a great way to ensure you're ready to move on to more advanced concepts. Treat these quizzes as milestones. Passing them means you're fully prepared for the next challenge. The guided labs are where you'll take the concepts from the lessons and apply them in a controlled, hands-on environment. These labs will take you step by step through tasks, including helpful feedback and hints. The more effort you put into the labs, the more you'll get out of them. It's all about learning by doing, so take your time and ensure you understand each step before moving on. After you've completed the guided labs, it's time to test your skills with independent projects or you-try-its. This is where you'll apply everything you've learned without step-by-step instructions. These projects are a great way to gauge how far you've come and to put your knowledge to the test. Don't worry if you feel challenged, that's part of the learning process. By completing these projects, you'll reinforce your skills and build confidence. Finally, at the end of the course, you'll complete a culminating hands-on project that you can use as a portfolio artifact. This project will showcase the skills you've gained throughout the course and give you something tangible to present to potential employers. As you progress through the program, these portfolio pieces will become stronger representations of your hands-on experience and understanding of key concepts. Success in this course comes down to using all the tools available. Watch the videos carefully, engage with the readings, complete the activities and quizzes thoughtfully, and take full advantage of the screencasts, labs, and projects. Each element of this course is designed to help you master the material step by step. By the end, you'll have a solid understanding of the concepts and real projects to prove your skills. Remember to persist, take your time, and you'll be ready for a successful career in development. Every successful coding project starts with a solid plan. By carefully organizing and outlining your project, you'll ensure all the parts come together smoothly. This process may seem like extra work, but it lays the foundation for success. With this plan in place, a developer can then write, debug, and optimize code to build dynamic, responsive applications. In this video, we will explain the end-of-course project. This project simulates real-world software development. You'll start by designing and planning an application, then building the basics, debugging, and refining your code as it grows more complex. By the end, you'll integrate everything into a polished final product. The goal is to experience the full coding process, writing, fixing, and improving your code. Before writing any code, you'll plan and design an application. This will involve defining project requirements and objectives and creating a design outline. With a plan in place, you'll then write the core features of your application. This step establishes basic functionality that will be expanded later. Once the core features are in place, errors will naturally appear. You should then focus on debugging, identifying issues, and ensuring everything works correctly. Refining your code at this stage is critical for smooth performance. As your system grows, debugging manually becomes time-consuming. Here we'll use Microsoft Copilot to help find and fix errors quickly. Copilot offers AI suggestions that streamline the debugging process and improves system performance. By the end of the project, the final product will be a polished system ready for use. In this project, you will go from planning to building, debugging, and refining your code. Following a structured process, you will create a functional system that mirrors the real-world development cycle. This experience will teach you the value of careful planning, problem solving, and using tools like AI to optimize your work.
Welcome to Introduction to Backend Development. In this module, we'll explore what it takes to build powerful applications behind the scenes, mastering a backend engineer's key tasks and tools. You will learn how to plan projects, manage code with Git and GitHub, and set the stage for dynamic development. Get ready to dive into the engine room of modern technology. We will begin by defining backend development and its crucial role in powering applications behind the scenes. We'll explore the core principles that guide effective backend development, laying the foundation for building robust, dynamic digital solutions. Then we will explore a backend engineer's different roles and responsibilities and understand the essential skills and technologies they use. We'll dive into the typical workflow and scope of backend engineering to see how these professionals drive the backbone of modern applications. Next, we will outline the key steps involved in planning a backend project and learning how to manage resources and documentation effectively to ensure smooth project execution. Then, we will identify the key tasks involved in backend development and explore how to manage workflows effectively to ensure seamless execution of these tasks. Next, we will explore how to effectively integrate project planning with development tools, ensuring smoother workflows and more efficient backend development processes. Finally, we will explore the fundamentals of Git and GitHub, exploring how these tools are essential for version control and collaborative backend development. By the end of this module, you'll have the knowledge and skills to plan, execute, and manage backend development projects confidently. You'll be well-versed in using Git and GitHub for version control and equipped to tackle any challenge that comes your way. Let's get started with Introduction to Backend Development.
My name is Ben Watson. I have been working at Microsoft for about 16 years. I work on the Bing platform team as a principal engineer. Well, I spend about half my day, heads down, focused on my projects, either working on code or planning and design. And maybe about the other half is meetings, emails, coordinating with others, working on presentations, or just doing research for the next projects. And it changes day to day, but that is, on average over a week or a couple of weeks. That is about what it seems like. Well, I invest considerable effort in ensuring that I have pretty good systems for organization. I've got project notes and task lists, keep my calendar up to date. And so I typically know what I'm going to work on, the day before, before I start that day. And so when I get to work, I'm ready to go and jump into, immediately a focused session of work. In my specific position right now, I spend a lot of time analyzing software performance, coordinating with other teams. I do spend a couple hours a day typically working on code on my specific projects. And then the rest of it is, preparing presentations, emails, all the typical administrative stuff, of corporate life. So I mostly work in the .NET space these days in C#. All of our repos are hosted in Git. I basically live in Visual Studio. We use Azure DevOps for running pretty significant amounts of automation, doing our tests, a lot of pipelines, and just managing our code and our processes. A little bit of C++ still. I don't think those components will ever go away, so I still am using that a little bit. And then we use PowerShell and Python for scripting. So recently I've been vetting the performance of .NET 9 on a major portion of the Bing stack. We're usually pretty aggressive adopters or even drivers of new features at the .NET runtime. So we want to make sure that nothing breaks for us and that performance is improved or at least hasn't regressed. And so I do extremely detailed performance analysis. I look at things from very high level latency all the way down to thread and memory allocation behavior. So that's one really big project I've been working on lately. Another one is I've been designing and planning the migration of our systems usage of some fundamental data format libraries that we have used for over a decade. And these are pretty fundamental pieces of our technology stack. But we need to migrate to newer versions just for functionality, for security, for performance reasons. And this whole effort will take months, if not over a year, and coordination among many other teams throughout Bing and Microsoft.
Hi, my name is Avanindra Parichuri. I'm a principal engineering manager here at Microsoft. I run the Microsoft Entra Gateway service. This is the gateway that takes in all the internet-facing traffic into the authentication stack. Previously, this was known as Azure Active Directory and currently Microsoft Entra. Sure, yeah. This really depends on the seniority of the engineer. And as you grow more senior in your role, a good part of your day actually goes towards contributing towards the success of others on the team. You do code reviews, you do design reviews, and when you find some time, you also write some code yourself. A significant amount of time is actually spent on investigations based on service health metrics such as availability and latency. This is especially true if you work on distributed systems with a high SLA, service level agreements, especially on my team as part of Azure. We run one of the largest services on the planet by traffic volume. And ensuring our service is always up and running and healthy from a customer's perspective is paramount, right? And in order to meet that bar, a lot goes on behind the scenes. And that's where these investigations come in. Any minor dip, even if it's not SLA impacting, any fluctuation from the norm, we treat that very seriously and we root cause that, right? So that's a major amount of time is actually spent on figuring out, hey, what's going on and how do we address the minor fluctuations, right? So yeah, that's how a typical day looks like. You do code reviews, you do design reviews, you write some code, and the rest of the time goes into running the service with a very, very high bar and an SLA. At Microsoft, for most large-scale services, there's automated alerting based on service health metrics and automated mitigations that kick in if things go wrong, right? But on top of that, we actually do manual reviews daily at least, and also many cases multiple times a day to ensure that there are no unexpected fluctuations, right? Even if they're not breaching the threshold of automated alerting, we still do that, right? If there are any undue spikes or dips we don't expect, especially in, say, availability, latency, request queuing requests add to the latency, right? The thread count, the garbage collector metrics, CPU usage, memory footprint, we immediately launch into an investigation, right? So typically this happens in an isolated part of the fleet. We're a global fleet of servers, right? And we kind of look at the isolated part of the fleet where this is happening, where we may have released a recent code update, right? So as part of the investigation, we go in and we collect various performance traces from the affected part of the infrastructure. We start analyzing those traces to get a clue towards what is happening. And we use those clues to gauge if any change that was done recently by us may have caused that, right? Then we isolate the change if we find it, and then we fix it, right? And sometimes during this investigation, using these traces, we find out, hey, it's actually not related to anything that our code was doing or is doing, or we released, and our service is running healthy. It might be due to a platform issue or a network issue that is causing our services to behave unexpectedly. Then we follow up with other teams responsible for the platform, and the investigation continues, and that's how the daily tasks go. Yeah. Primarily, I work with the programming language I work in is C#, and the technology is .NET Core. So that's our primary language and primary technology, but there is also a certain bit of C++. We use PowerShell, and if we're talking about technologies, obviously Azure. Everything we do is Azure based, so Azure plays a major part of running our services. Recently, I worked on this project called Microsoft Entra's certificate-based authentication project. This was a public project, and the key improvement from this project was user experience when signing in with a client certificate, right? Usually, as a user, when you browse to a website that requires client certificates, you would see a pop-up with various certificates, and you as a user have to choose which, hey, this certificate or that certificate, right? So to authenticate to that web server. And that can be a confusing experience. Which certificate do I choose for which website? That's a thought I know I've had many times, right? With this project, we made it completely automatic. The user doesn't have to choose based on a pop-up. The server and the client, they both collaborate to pick the right one automatically, and there's no button clicks from the user required, right? So that's the problem statement of the project. And with respect to how we did it, yeah, so one of the key requirements in this project was the ability to install customer TLS certificates and TLS hints, as we call them, on our servers in a matter of seconds at runtime, right? And the major difference compared to previous tech was that previously, in order to install these certificates and hints, it would take us weeks to do it, and it could only be changed at server startup, meaning we had to wait for deployment time when the server's not doing anything. Bring it down, restart the server, and apply the hints, right? Here, the requirement was, in order to do this, we had to install the certificates, the hints, and also do it at runtime when the server's already taking traffic, right? So that was the major thing. We had to install them really, really fast and safely with zero downtime. And we did most of this, all of it almost, 99% of it with .NET APIs, doing native interop with the operating system web server APIs to get it done. It was pretty challenging, but hugely satisfying to see the results in the end, with customers absolutely delighted with this user experience improvement.
Think about the last time you used an online store. You effortlessly clicked through products, added items to your cart, and maybe even received personalized recommendations. But have you ever wondered what's happening behind the scenes to create that seamless experience? That's where back-end development comes into play, making sure everything runs smoothly from your clicks to your final purchase. In this video, we will define back-end development. But before we explore back-end development, let's first examine the front end, the part of the application that users interact with directly. The front end is the part of the application that runs directly on the user's device, whether it's a browser, mobile app, or desktop. This includes everything a user interacts with, like text, images, buttons, and forms. For example, when you visit your favorite online store, the layout, colors, and fonts you see are all created by front-end code that runs in the browser. Although front-end code allows users to interact with applications, relying solely on front-end code has limitations. First, the user's device might not have the power to process complex tasks, such as real-time video streaming or processing secure payments. Second, Front-end code is accessible to users, which means it can be easily viewed or even modified by anyone with access to the browser's development tools. This makes it vulnerable to security issues like hacking. Finally, front-end code needs to communicate with databases and services to manage data. But it can't directly interact with these resources because it runs in a secure, limited environment like a web browser. Because front-end code has these limitations, especially when it comes to handling complex tasks and securing data, developers rely on servers to pick up where the front end leaves off. Servers are powerful computers that store data and run the software needed to show web pages or applications. Servers receive requests, process data, and send a response. For example, when you type a URL, your browser sends a request to the server. The server receives the request and processes it, usually interacting with the database to receive information. Then the server sends the data back to your browser, and your browser shows you the web page. Servers are critical to a functioning backend. The backend is the part of the application that runs on the server. It manages connections with the database, processes requests, and ensures that everything functions smoothly. With a clear understanding of how the backend supports the front end, it's time to explore how developers can work across both areas. This is where full stack development comes into play, bridging the gap between front end and back end to create a cohesive, seamless user experience. Full stack development is the development of both the front end and the back end of a web application. Full stack development requires a broad skill set, from designing interactive web pages that the user sees and interacts with to writing server-side code that processes data and ensures everything functions correctly behind the scenes. Full stack development also requires a deep understanding of how these two areas communicate with each other. For example, when a user submits a form to a website, the full stack developer needs to ensure that the front end captures the user's input correctly and that the back end processes this data securely and efficiently. So exactly how do back end and full stack engineers bring the front end and back end together to create a seamless user experience? Well, it all comes down to effective communication between the two. The key interactions that allow them to communicate include middleware, APIs, and static content serving. Let's examine how each of these work in more detail, beginning with middleware. Middleware facilitates smooth communication between the front end and the back end. Middleware is software that sits between the front end and back end, managing communication between the two. It acts like a translator, ensuring that the data exchanged is properly understood and processed by both sides. For example, when you make a purchase, middleware checks your login credentials before allowing the transaction. While middleware facilitates communications within the application, APIs, another key component, extend this interaction by enabling different software systems to talk to each other. APIs are like bridges that allow different software systems to communicate with each other. They define the roles and protocols for accessing data or service between different software systems. Let's explore how APIs play a crucial role in connecting the front end with the back end. For example, when you make a credit card payment for your products, it's likely using APIs to talk to the credit card companies and process the payment to remote servers. Beyond dynamic interactions, there's another aspect to consider: static content serving. This process is essential for the delivery of unchanging files like images or style sheets directly from the server to the front end, ensuring that users experience fast load times. For example, an online shopping site will have product images and descriptions that are served directly to the front end. This means you can see these items almost instantly when you visit the site. As you can see, each interaction plays an important role in ensuring that the front end and back end work together and provide a user-friendly experience. In this video, we defined back-end development and explained its role in web development. We also covered the front end, its limitations, and the interactions between the front end and the back end that allow them to communicate. Whether you're focused on front end, back end, or becoming a full-stack developer, understanding these concepts will be key to building powerful and efficient applications. When you visit your favorite website or app, have you ever wondered what makes it work seamlessly every time you interact with it? Imagine walking into a restaurant. You see the menu, place your order, and enjoy your meal, all in the front of the house. But what happens is you don't see the bustling kitchen in the back, where ingredients are prepared, meals are cooked, and everything comes together to deliver your experience. Think of the back-end development as the kitchen of a restaurant. You don't see it, but it's what makes everything run smoothly. The front end is what the users of the application you're developing see and interact with, just like the front of the restaurant. In this video, we will explain back-end development. Let's begin with the definition of back-end development. Back-end development is the practice of building and managing the systems that power apps and websites, such as data processing, storage, and application logic. It's what goes on behind the scenes of websites and applications you use every day, including the one you are using right now to take this course. Back-end development focuses on servers, databases, and application programming interfaces. Let's explore each of these in more detail, starting with servers. Servers are powerful computers that store data and run the software needed to show web pages or applications. Servers receive requests, process data, and send responses. Understanding servers is crucial because they handle all the logic, database interactions, user authentication, and more. Essentially, servers make the front end interactive and functional. This involves server-side scripting. Server-side scripting involves writing code that runs on the server instead of the user's browser to generate dynamic web pages, handle user input, and manage application logic. For example, when you log into your favorite social media site, code runs on the server, checks your credentials, and grants you access. The next back-end development focus is databases. A database is like a digital filing cabinet where all the data is stored. This might include user information, product details, or any other data an application needs. Databases are a tool to store, organize, and manage data efficiently. This involves database management. Database management ensures that data can be quickly accessed, updated, and retrieved whenever needed. For example, when you search for a product on an e-commerce site, the database retrieves the relevant product information and displays it to you. And when you make a purchase, the database updates the inventory and records that transaction. Without databases, the site would struggle to handle large amounts of data, leading to slower performance, less reliable data access, and potential data loss. Lastly, back-end development focuses on application programming interfaces, or APIs. APIs are like bridges that allow different software systems to communicate with each other. APIs define the rules and protocols for accessing data or services between different software systems. For example, when you make a credit card payment for your products, it's likely using APIs to talk to the credit card companies and to process the payment on remote servers. This involves API integration. API integration is the process of connecting two or more applications using APIs to exchange data and perform actions. APIs enable websites and applications to connect with other services, enhancing their capabilities without the need to build new features from scratch. Now that you've learned about the three primary parts of back-end development, let's explore the core principles of back-end development. They are performance, scalability, security, and reliability. When developing the back end, you would consider the principle of performance. Performance refers to how quickly and efficiently the site or applications respond to user requests. High performance ensures a smooth user experience, which is essential for retaining users and maintaining satisfaction. To achieve this, back-end developers focus on writing efficient code that minimizes resource usage and maximizes response speed. They also monitor and manage server resources to handle varying loads and optimize performance. While performance ensures your application responds quickly, it's just as important to consider how it will handle increased demand. Next, let's explore the principle of scalability. If you are developing the backend for an e-commerce store, you would want to consider the site's ability to handle increased traffic during sales periods by scaling resources. This is the principle of scalability. Scalability ensures a website or application can grow and handle more users, data, and processes. While scalability ensures your application can grow with demand, it's also crucial to protect that growth. Next, let's consider the principle of security. Security is critical to protect sensitive data, maintain user trust, and comply with legal regulations. Security in back-end development involves protecting data and applications from threats. You would develop the site to keep important information such as credit card numbers and customer information safe. To do this, back-end developers implement secure data handling by protecting data at rest and in transit through encryption. They also focus on managing access controls to ensure that only authorized users can access sensitive data and functionalities. After ensuring performance, scalability, and security, it's essential that your application consistently uphold these principles. This brings us to the principle of reliability. Reliability is the ability of a system to function correctly and consistently over time. For example, a reliable e-commerce platform consistently processes orders without downtime, even during peak shopping periods. To achieve this, backend developers start with graceful error handling, ensuring the system can handle errors without crashing. They also implement comprehensive logging to capture errors and operational data, which is crucial for diagnosing issues and understanding system behavior. All of these principles help ensure that backend development creates well-functioning applications. In this video, we covered the role of servers, databases, and APIs in backend development. We also covered the core principles, including performance, scalability, security, and reliability. Understanding these concepts is crucial for building efficient, reliable, and scalable web applications. In the world of web development, backend engineers are responsible for the systems that ensure everything functions seamlessly. In this video, we will describe the key tasks and responsibilities of a backend engineer. Backend development is the practice of building and managing the systems that power apps and websites, such as data processing, storage, and application logic. With that foundation in mind, let's explore the daily tasks of a backend engineer. Backend engineers have a variety of daily tasks that ensure the smooth operation and development of applications, including writing server-side code, managing databases, optimizing server performance, and debugging issues. Most backend engineers spend a significant portion of their day writing server-side code, which involves creating the logic that powers the application. Backend engineers write server-side code in languages like C#, JavaScript, Ruby, and Python. Backend engineers also spend time managing databases. A database is a system where an application's data is stored, retrieved, and updated. Additionally, backend engineers are responsible for designing, maintaining, and optimizing these databases to ensure they perform well and handle large volumes of data. Examples of this include tasks like structuring the data, writing queries to interact with the database, and ensuring data integrity. Another important task is optimizing server performance. This means ensuring the server runs efficiently so that the application can handle many users without slowing down. Backend engineers do this by caching, improving database queries, and adjusting server settings. Finally, debugging is a key part of backend engineers' day. When issues arise, such as errors in code, slow performance, or unexpected behaviors in the application, it's the backend engineer's job to identify the root cause and fix the issue. All of these daily tasks help backend engineers with their primary responsibilities. Now, let's explore some of the backend engineer's primary responsibilities. Backend developers' primary responsibilities include API development, data management and security, performance optimization, and system reliability and maintenance. Let's examine each of these responsibilities in detail, starting with API development. First, backend engineers are responsible for API development, which includes creating, documenting, and maintaining APIs. An application programming interface, or API for short, is a set of rules and tools that allows different software applications to communicate with each other. Backend developers enable seamless data exchange and functionality across various systems by ensuring that APIs are efficient, secure, and well documented. Backend developers are responsible for data management and security. Data is information that is collected, stored, and used by computers, often in the form of text, numbers, or other formats, to drive decisions and operations in various applications. Data management and security involves managing the flow of data, storing data efficiently, and protecting sensitive data. Another responsibility of backend developers is performance optimization. Performance optimization begins by backend engineers writing efficient server-side code. They also monitor how many resources a server is using and adjust server settings to handle high traffic. Resources refer to the computational power, memory, storage, and network bandwidth that a server uses to perform tasks and run applications. Performance optimization is about making sure that the entire system can scale and perform under varying levels of demand. Finally, backend engineers are responsible for system reliability and maintenance. This includes robust error handling, logging, regular maintenance, and updates. Error handling is the process of detecting and managing errors to prevent them from disrupting the system. These practices help backend engineers quickly identify and address issues, minimizing downtime, ensuring a stable user experience, and keeping the system secure and functioning at its best. Additionally, effective collaboration is essential for backend engineers to complete their daily tasks and responsibilities. They work closely with front-end developers, DevOps engineers, UX, UI designers, and project managers to ensure the final product meets all requirements. Let's explore how backend engineers collaborate with these roles in more detail, beginning with front-end developers. Backend engineers collaborate with front-end developers to integrate the user interface with backend development, such as databases, APIs, and server logic. For instance, a backend engineer might collaborate with a front-end engineer to ensure that when a user fills out a booking form, the database is designed to store their responses properly. Backend engineers also collaborate with DevOps engineers to make sure the application is set up, runs smoothly, and stays reliable. For example, a backend engineer might collaborate with a DevOps engineer to set up a server to host a new application, ensuring it's properly configured to handle user traffic and operate smoothly. They must also collaborate with UX/UI designers to make sure the technical side of the application matches the design vision. They ensure that the app provides the right information and features so users have a smooth and enjoyable experience. For example, a back-end engineer might collaborate with a UX/UI designer to ensure that when a user clicks a button to view their account details, the app quickly retrieves and displays the correct information in a way that looks good and is easy to use. Lastly, back-end engineers must collaborate with project managers. Project managers help back-end developers by defining project scopes, creating realistic deadlines, and managing resources efficiently. Back-end engineers might meet with project managers during a daily stand-up, or sending them a quick chat message to update them on their status. Clear and consistent communications with the various roles on the development team helps ensure all team members are aligned and can work together effectively. In this video, we described the key tasks and responsibilities of a back-end engineer. We covered daily tasks such as writing server-side code, managing databases, optimizing server performance, and debugging issues. We also discussed key responsibilities including API development, data management and security, performance optimization, and system reliability and maintenance. By mastering these areas and collaborating with your teammates, you can become an effective back-end engineer, contributing to the development of robust and scalable applications. From managing databases to optimizing server performance, backend developers need a broad set of skills and knowledge across a range of systems to ensure applications run smoothly and securely. In this video, we are going to explain the critical skills and technologies required for backend engineering. Backend engineers need a few critical skills, including server-side programming languages, frameworks, libraries, database management systems, and tools and technologies. Let's explore these skills in more detail, starting with server-side coding languages. Server-side coding languages are the fundamental building blocks for creating web applications. They consist of a set of instructions that allow humans to interact with computers. These include server-side programming languages like C#, JavaScript, and Python. Backend engineers use server-side coding languages to handle logic, database interactions, and server configurations that power websites and applications. These languages process user inputs, manage data flow, and ensure that web applications run smoothly. Mastering server-side languages is just the beginning. As you grow as a backend engineer, you'll also need skills in various frameworks that streamline your development processes. Frameworks are pre-written code structures that provide a foundation for building applications. They offer a standardized way to build and organize code, making development faster and more efficient. Popular backend frameworks include ASP.NET for C# and Django for Python. These frameworks simplify the development process by providing tools like reusable components. Another skill that can help developers streamline the development process is using libraries. Libraries are collections of pre-written code used to perform common tasks. They often include objects and functions used individually to solve specific problems. They allow engineers to control the application's flow, add custom code, and select only the components they need. Popular libraries include NumPy for Python and jQuery for JavaScript. The terms framework and library are often used interchangeably, but they serve different purposes. Imagine a framework as a pre-built Lego set where the pieces fit together in a specific way to create a particular model, while a library is like a box of assorted Lego pieces you can use to build anything you want. Now let's examine the skill of using database management systems. Database management systems are software tools that manage, store, retrieve, and organize data in a structured way. Database management systems ensure data is easily accessible, secure, and consistently maintained across an application. Mastering database management systems means knowing how to design, set up, and manage databases. It also means optimizing performance, securing data, and keeping data as accurate as possible as applications grow. This skill lets backend developers build systems for fast, accurate data access, ensuring a smooth user experience. For example, when a customer places an order, the database management system efficiently updates inventory levels and the customer's order history in real time. Finally, let's discuss the tools and technologies that backend engineers use daily, including version control systems, containerization tools, and continuous integration, continuous deployment tools. Let's understand more about the tools and technologies backend developers use, starting with version control systems. Version control systems are tools that track and manage changes to code over time, allowing multiple developers to collaborate on the same project without overriding one another's work. Backend developers need to know version control systems like Git because they make teamwork and project management easier. When multiple developers work on the same project, version control ensures that their changes fit together smoothly. It also lets developers experiment with new features safely by keeping the main codebase stable. The ability to manage different versions of the same codebase and merge changes effectively is key to keeping the project on track and avoiding issues. Next, backend developers should know about containerization tools like Docker and Kubernetes. Containerization tools allow developers to package an application and its dependencies into a single container that can run consistently across different computing environments. Containers are the basis of containerization tools. Containers are lightweight, portable units that package an application and all its dependencies, like libraries, frameworks, and configurations, into a single, consistent environment. This enables it to run the same way whether you're developing, testing, or deploying it. As a backend developer, you need to understand containerization and know about containerization tools because they simplify deployment, ensure consistency across environments, and make it easier to scale applications. With containerization, developers can be confident that the application will behave the same way, no matter where it's deployed. Finally, backend developers should be able to use continuous integration and continuous deployment tools like Jenkins or GitLab CI. Continuous integration and continuous deployment tools, also known as CI/CD tools, automate the process of integrating code changes, testing them, and deploying them to production environments. Continuous integration ensures that code is integrated into the main codebase regularly, reducing the risk of conflicts and errors. Continuous deployment automates the process of releasing updates to production, ensuring that new features and fixes are delivered quickly and reliably. This skill is important for backend developers to maintain a smooth, efficient development workflow and to quickly deliver updates and new features to users. In this video, we explained the critical skills and technologies required for backend engineering. We covered essential technical skills such as coding languages, frameworks, libraries, database management systems, and tools and technologies. By mastering these skills and using the right tools, you can become a proficient backend engineer capable of building robust and efficient applications. Imagine you're tasked with constructing a skyscraper, but you have no blueprint or plan. How would you ensure that the building stands tall and strong? Just like in construction, back-end engineering projects require a solid foundation and a well-thought-out plan to be successful. In this video, we will describe the scope of back-end engineering projects and the workflow involved in executing them. Let's start by exploring the stages of a back-end development project. These projects typically involve following a series of stages, including initial planning, system architecture, design, development, testing, and deployment. The initial planning stage is where developers lay the groundwork. The project begins with the gathering requirements and defining objectives. This stage involves collaborating with stakeholders to ensure the project meets user needs. Good planning ensures a successful project by ensuring everyone involved has a clear vision of the end product. Once the groundwork is laid through careful planning, the focus shifts to the system architecture design. Here, back-end engineers take a project's blueprints and begin crafting the structural framework that will bring the back-end system to life. During this stage, they define the system components by breaking down the application into smaller components, such as databases, servers, APIs, and services. Then they decide how these components will interact and communicate with each other. During this stage, engineers also design components such as databases and APIs. They map out how the data will move through the system, how it will be stored, and how it will be accessed. They also design how communication will occur with APIs. With the system components clearly defined and designed, engineers move on to develop documentation. They create visual representations of the architecture and document design decisions to guide the development process. Armed with this comprehensive planning and design, the project is ready to enter the development stage, bringing the architectural plans to life. Using coding languages like C# and Python, engineers bring the designs to life, deploying servers, building APIs, and setting up databases. During this stage, engineers follow best practices in coding to ensure that the code is clean, efficient, and maintainable. Throughout the development process, testing is an integral part. Developers frequently test their code as they write it, using unit tests, integration tests, and other methods to catch and resolve bugs early. Once the testing confirms the software's reliability, the project is ready for the final stage, deployment, where the finished product is released to users. This involves transferring code to a live server where it can be accessed by end users. Effective deployment strategies ensure that an application is reliably available and performs well. Collaboration and communication with stakeholders are essential to ensure that the front-end and back-end systems work together seamlessly. This is called integration. Back-end interfaces don't exist in isolation. They must integrate with front-end interfaces. Integration is a key aspect of back-end development, where the back-end systems must seamlessly connect with front-end interfaces and other systems. This involves not only creating and managing APIs to enable communications between different parts of an application, but also integrating with databases, authentication services, middleware, and third-party services. Beyond the technical side, successful integration requires clear communication and collaboration with other developers and stakeholders. This helps to align objectives, address issues promptly, and ensure all systems work together smoothly, resulting in a cohesive and reliable application. To manage the project stages and the collaboration, teams adopt a workflow methodology. Workflow methodologies are structured approaches used to organize and manage the steps and tasks involved in a project. Different methodologies provide various frameworks for collaboration, task management, and project tracking. There are several workflow methodologies to choose from, each with its own strengths and weaknesses. Waterfall methodology is a linear approach in which each stage of the project must be completed before proceeding to the next. This approach is straightforward but can be inflexible. Another workflow methodology is XP, or extreme programming. This methodology emphasizes frequent releases, continuous feedback, and close collaboration between developers and users. XP focuses on improving software quality and responsiveness to changing requirements. Agile methodology, however, is particularly popular in engineering. Agile is an iterative approach that promotes flexibility and customer collaboration. In Agile, projects are divided into smaller, manageable chunks called sprints, which typically last 2 to 4 weeks. At the end of each sprint, the team reviews progress and plans the next steps. Agile methodologies allow back-end engineers to adapt to changes quickly and continuously improve their work based on feedback. To manage the project stages efficiently and develop an excellent product, back-end engineers follow some best practices. First, back-end engineers must prioritize their tasks. They organize tasks based on their importance and deadlines. They use project management tools like Jira, Microsoft Planner, Trello, and Asana to help manage and prioritize tasks efficiently. They also use version control tools to manage code changes and collaborate effectively. Code reviews are another important practice. Code reviews involve having other developers review your code to catch errors, improve quality, and share knowledge within the team. This enables engineers to maintain code quality and share knowledge among team members. Finally, they implement deployment strategies such as continuous integration, or CI, and continuous deployment, or CD, pipelines to automate the deployment process. This ensures that updates are deployed frequently and reliably. In this video, you learned about the scope of back-end engineering projects and some key best practices for workflow management. Understanding the scope and workflow of back-end engineering projects is critical for delivering high-quality web applications. By following structured project stages, collaborating with front-end engineers to seamlessly integrate with back-end systems, and adhering to best practices, back-end engineers can create efficient, user-friendly, and robust applications. Planning a back-end project can feel like planning an international trip. There are many things that you need to get done, and they all have to be completed in a strict timeline, requiring planning and coordination. Just as a well-planned trip ensures you reach your destination without hiccups, careful planning of a back-end development project sets the stage for successful execution. In this video, we'll describe the foundational steps for planning a back-end project. By better understanding these phases, you'll have insights into how to make a project successful and even enjoyable. Planning a back-end development project unfolds across 4 key phases. These phases are defining project requirements, setting objectives, creating timelines, and identifying resources to guide the development process. Let's explore each of these in more detail, starting with defining project requirements. The defining requirements phase is where you lay the foundation of your project. This phase focuses on pinpointing exactly what needs to be built, who it's for, and why it's necessary. which involves engaging with stakeholders to gather the necessary details that outline what your project aims to achieve. Consider you're tasked with enhancing a library's database system. In this phase, you might pinpoint a need for enhancing the library catalog's backend by implementing a new search function. This function is designed to improve search capabilities significantly, ensuring faster data processing and retrieval. It will be designed for the library staff who manage the system and the patrons who use it daily. The enhanced functionality is needed because the current system could be faster and more convenient, and the upgrade will provide quicker, more accurate processing to information. When you define project requirements well, you align the project with the client expectations and the user's needs. This goes a long way towards ensuring that the final product is both functional for the user and satisfactory to the client. Once the project requirements are clear, the next phase is about setting objectives. This phase is where you shift from understanding what needs to be done to figuring out exactly how you will achieve those goals. Well-defined objectives will guide every decision you make moving forward. Project objectives are specific results that a person or process aims to achieve within a time frame and available resources. Project objectives should be SMART, which stands for specific, measurable, achievable, relevant, and time-bound. This framework helps you create objectives that are clear and actionable, ensuring your project stays on track. For example, an objective of our library's database could be develop and implement enhanced search functionality that reduces search time by 50% within the next 6 months. This clear objective provides a roadmap for the project. They help to focus the project team's efforts and allocate resources effectively. With project requirements and objectives firmly in place, the next step is creating timelines. Creating timelines involves scheduling all tasks and milestones from start to finish. This helps the project team track progress and know when work items are due. Creating timelines will set expectations for project completion so that all teams involved will know when the back-end work will be done. For example, you might plan the new search function's initial design will take 1 month, followed by 3 months of development and 2 months of testing and deployment, aligning with your objective's 6-month timeline. Timelines are the cornerstone of your project plan. They drive the completion of tasks and establish when specific deliverables will be completed. Timelines are necessary, but they're only part of the equation. To bring your project to life, you need the right people, systems, and tools. Let's explore the final phase, identifying the resources that will power your project. Project resources are the assets, materials, and human capital needed to complete a project successfully. Identifying the resources a project will need includes determining what tools, technology, and team members are required to complete that project. For example, you might need to select the server architecture to build the enhanced server functionality, how many backend developers and database administrators you'll need, and to make sure there is budget for resources like cloud infrastructure and database optimization tools. Proper resource allocation ensures that the project has everything it needs to succeed, reducing the risk of resource shortages and budget overruns. As you build the project plan, each phase is guided by the scope of the project. The project scope outlines the project's boundaries, ensuring everyone involved understands what is included and what is not. Knowing these boundaries allows you to accurately define project requirements, align objectives with established limitations, effectively create timelines, and identify necessary resources. In this video, we covered the 4 phases of back-end project planning, including defining project requirements, setting objectives, creating timelines, and identifying resources to guide the development process. We also covered how the project scope informs these planning phases. Understanding these concepts ensures careful planning of a back-end development project and sets the stage for successful execution. Imagine trying to build a house without the right blueprints, tools, or expertise. Plumbing leaks, electrical issues, and collapsing walls could be disastrous results. Similarly, a back-end project can fail just as dramatically without proper resource management and documentation. In this video, we'll explain the importance of resource management and documentation in back-end project planning. First, let's explore resource management. Resource management involves identifying and allocating the necessary resources for a project to ensure that it is completed effectively and efficiently. Let's break this down, starting with resource identification. Identifying the right resources is the first step in resource management and perhaps the most important. You must clearly understand the project's scope and objectives. So you might review the project specifications and details. Imagine you're tasked with building the back-end system for a rocket ship. You would need to know the specific functionalities the rocket's back-end must support, like navigation controls, fuel management systems, and communication networks with ground stations. Next, you would assess what skills, specific tools, and technologies are necessary, including specialized software and programming languages. Building navigation controls might require developers proficient in Python, version control tools like Git, and simulation software. Once you know what's needed, evaluate what you already have and determine where there are any gaps. For instance, do you have engineers' experience in Python and high-stakes environments? Is there existing infrastructure that can support the new backend requirements, or do you need to upgrade and acquire new systems? Once you've identified the resources you need, the next step is allocating them effectively across the project. Resource allocation is the act of assigning resources to different parts of the project at the right times. Team members, tools, and technology should all be allocated. For team members, assign roles by clearly defining who is responsible for each task. Then, distribute tools and technologies to ensure all team members can access the necessary tools and resources. Efficient resource allocation ensures that all aspects of the project are adequately supported, enabling the team to work efficiently, meet deadlines, and prevent resource wastage. For example, ensuring that there are enough software licenses available prevents delays that occur when team members cannot access necessary tools. Along with resource management, you need to have effective communication. Effective communication is the backbone of any successful project, especially when building something as complex as a rocket ship's back end. Effective communication is the clear, consistent, and timely information sharing among all team members and stakeholders. Let's explore some strategies. First, let's discuss communication channels. Communication channels are the way people share information, such as chat, email, phone, or other dedicated platforms. Each channel has unique characteristics that affect how messages are delivered and understood. For instance, using a chat for quick updates and queries, email for detailed communications, and dedicated platforms for project management ensures that every piece of information is correctly placed and easily accessible. Next, it's important to schedule regular meetings to discuss progress, address challenges, and share updates. Whether daily stand-ups or weekly project updates to executives, these meetings help keep the project timeline on track and allow for real-time problem solving. Another important strategy is establishing feedback loops. This means creating a system where team members can give and receive constructive feedback on work, progress, and issues. After establishing strong communication strategies, the next step is to ensure that every discussion and decision is properly documented. Documentation helps keep everyone on the same page and preserves the project's integrity. It ensures that all team members, regardless of when they join the project or their role, have access to the latest updates and decisions. Let's look at the project documentation in more detail. Project documentation involves recording all aspects of the project, from initial planning to final delivery, to ensure clarity and continuity. Comprehensive documentation provides a reference point for the team, ensuring transparency and facilitates the onboarding of new team members. Common types of project documentation include the code base, which contains the project source code, the project plan, which outlines the entire project timeline, the requirements doc, which details what the project must achieve, progress reports to track ongoing development, and technical documents that explain how the systems work. All documentation should be stored in a place accessible to all stakeholders. Cloud-based sharing tools can effectively serve this purpose, acting as a single source of truth for the entire project. In this video, we cover the importance of resource management and documentation in back-end project planning. First, we explored how identifying and allocating resources ensures project efficiency. Next, we discussed the importance of clear communication channels for regular updates. And finally, we emphasized the role of thorough documentation in maintaining project integrity and facilitating team collaboration. Imagine you're setting up the backstage for a big concert. Everything that happens behind the scenes, from setting up the stage to managing the sound system, is crucial for the show to run smoothly. Similarly, in backend development, there are tasks that are important for the smooth operation of a website and apps. In this video, we will identify the essential tasks in backend development. Backend development involves the server-side aspect of web development, focusing on server environments, business logic, databases, and API creation and integration. Let's begin our exploration of backend development by understanding how to set up a server environment. A server environment is where your backend code runs. Think of it as the engine room of your application. It handles everything from processing requests to managing data and sending responses to users. Setting up server environments is like preparing the backstage area for your concert. You must ensure everything is in place so the show can go on without a hitch. Let's break the tasks of setting up a server environment into 4 steps. Step 1, choose a server. Step 2, install software. Step 3, configure the server. And step 4, prepare for deployment. First, you will need to choose a server. This is like picking the right venue for your concert. Server environments have 3 components: a physical or virtual machine, an operating system installed on the machine, and the server software running on the operating system that handles the web requests. In this step, you might select all 3 components, or you might only choose the server software. Next, you'll need to install the necessary software and frameworks. Think of this as setting up the stage and sound equipment. This step includes installing the chosen server software, any necessary programming languages such as Python or Node.js, and any frameworks that your application will depend on. The next step is configuring the server. This is like adjusting the sound system to get the best acoustics in the venue. This involves configuring security settings like firewalls and SSL certificates, and optimizing performance settings to handle your specific traffic load. The final step in setting up a server environment is preparing the server for application deployment. This typically involves setting up any necessary environment variables, ensuring that the server is properly connected to the database and other services. Another key task in backend development is implementing business logic. Business logic refers to the rules, calculations, and processes that determine how data is created, displayed, sorted, and changed within an application. It's like planning the concert schedule, deciding which bands play when, how long their sets are, and what kind of music they perform. In backend development, implementing business logic involves writing the code that defines how your application behaves. For instance, you might write rules for processing user requests or handling transactions. It also involves implementing security measures within the business logic to protect data. Along with implementing business logic, managing databases is another key task in backend development. Managing databases is all about organizing and storing data, like organizing the instruments backstage at a concert. This task involves setting up databases, creating tables, and defining relationships between different data points. Think of it as ensuring every instrument is in the right spot and ready to be used. Creating and integrating APIs is another key task in backend development. APIs, or application programming interfaces, are the messengers that pass information between the different parts of your application. Think of them as the roadies who carry messages and equipment between the stage and the control room. Creating APIs involves defining how different parts of your application communicate, writing the server-side logic for each endpoint, and ensuring the endpoints can communicate efficiently and securely. It's like making sure the band and sound engineers can communicate perfectly during the concert. For each of these backend development tasks, it's important to test and debug. In development, testing is the process of assessing and confirming an application does what it is supposed to do and is free of errors. On the other hand, debugging is the process of identifying errors in the code and their causes and resolving them. Testing and debugging are crucial to make sure everything runs smoothly, just like sound check before the concert starts. Testing involves writing and running various tests to simulate real-world usage and discover issues. Debugging involves using debugging tools to identify and resolve bugs. Regular testing and debugging help maintain the application's reliability and performance, ensuring a smooth user experience. In this video, we identified the essential tasks in backend development, including setting up the server environment, implementing business logic, managing databases, and creating APIs. You also learned the importance of testing and debugging. Understanding these tasks is crucial for building robust and efficient back-end systems. Imagine a busy restaurant kitchen where orders are efficiently taken, prepared, and delivered. Multiple chefs, sous chefs, line cooks, and waitstaff must work together to prepare various dishes simultaneously. Each role is critical, and without a well-organized system, the kitchen would descend into chaos. Similarly, in back-end development, an efficient workflow ensures that projects progress smoothly and efficiently. Whether you're working on a small project or contributing to a large code base, effective workflow management is essential. In this video, you'll learn about best practices for managing workflows in back-end development. Workflow management is the process of organizing, documenting, and optimizing the steps involved in software development to ensure smooth and efficient project execution. There are a variety of methodologies commonly used for workflow management, including Agile, Waterfall, Lean, and Extreme programming that are used to guide development processes. Let's explore how Agile methodology is used to structure workflows effectively. Agile methodology is a project management approach that emphasizes iterative development, collaboration, and flexibility with the goal of enabling teams to adapt quickly to changes. Agile methodologies help manage workflows by breaking projects into smaller, manageable pieces. Each of these pieces is known as a sprint, which generally spans 2 weeks of development time. A major benefit of Agile is that there is a working product at the end of each sprint. There are 3 key concepts to the Agile methodology: roles, ceremonies, and artifacts. Let's explore each of these concepts in detail using our example. In Agile, the roles include the product owner, who defines the product vision and prioritizes work, the Scrum Master, who facilitates the process and removes obstacles, and the development team, who works together to deliver the product. Violet, a senior teammate, is the product owner. As product owner, Violet is responsible for defining the features of the product and deciding on release dates. She also prioritizes the product backlog and ensures the team delivers value to the customers. Violet identifies features for the content management system that include a content editor. Amir is the team's Scrum Master. He ensures that the team follows Agile principles and practices. He facilitates meetings, removes blockers, protects the team from outside interruptions. Finally, there are 8 of you on the development team. You are a cross-functional group that works on delivering the product. During the sprint, the team collaborates to turn the content editor backlog items into working product features. Next, let's explore Agile ceremonies. Agile ceremonies are structured meetings designed to facilitate planning, team communications, and continuous improvement throughout a project's lifecycle. Next, let's break down the Agile ceremonies. These are structured meetings that help maintain the flow and efficiency of the development process. These include sprint planning, where the team sets goals, daily stand-ups, which keep everyone on track, sprint reviews, where progress is assessed, and retrospectives, where the team reflects on improvements. Before the sprint begins, Violet leads the team in a sprint planning meeting. In this bi-weekly meeting, the team plans the work to be done in the upcoming sprint. They discuss the highest priority backlog items and decide how much work they can commit to. During sprint planning, the team agrees to complete the content editor features in the next 2 weeks. Once the sprint begins, Amir schedules daily stand-ups. In these short daily meetings, each member shares what they did yesterday, what they will do today, and any blockers they are facing. During a daily stand-up, Chris, a developer, reports a blocker related to integrating a third-party authentication service, prompting Amir to assist in resolving it. When the sprint is coming to an end, Violet leads the development team in a sprint review with stakeholders. In this longer bi-weekly meeting, the team demonstrates the working product to stakeholders and discusses what they accomplished. At the sprint review, the team demonstrated the new content editor features to stakeholders, showing how it allows users to create and manage content seamlessly. After the new sprint review, Amir leads the team in a retrospective. In this meeting, Amir asks the team to reflect on the sprint process and discuss what went well, what could be improved, and how to make improvements in the next sprint. In this retrospective, the team identified that better communication tools are needed to streamline feedback on code reviews. Now, let's examine what Agile artifacts are. Agile artifacts are tangible deliverables used to track progress throughout an Agile project. Agile artifacts include user stories, which capture the requirements from the user's perspective, the product backlog, a prioritized list of features and tasks, and the definition of done, a checklist that ensures a task meets the quality standards before it's considered to be complete. Agile user stories are brief, simple descriptions of a feature told from the perspective of the end user, outlining their needs and the desired outcome. A user story for the content editor feature might be, as an editor, I want to easily format text so that my articles are visually appealing. The product backlog is a prioritized list of all features, enhancements, and bug fixes that might be needed in the product. The backlog might include items such as user authentication and analytics reports. The definition of done is a clear, agreed-upon set of criteria that specifies when a task, user story, or project is considered complete and meets quality standards. A feature is considered done when it passes all automated tests, code reviews, and is deployed to a staging environment for final testing. Together, these three agile concepts, roles, ceremonies, and artifacts, establish a clear and organized workflow that enhances flexibility, encourages continuous improvement, and ensures that the development process is focused on delivering value to users. In order to manage ceremonies and artifacts, many development teams use specialized workflow management tools. Project management tools such as Jira, Trello, and Asana have a specific focus on agile workflows. These tools help developers know what work needs to be completed. Using these tools not only helps manage ceremonies and artifacts, but they also help streamline workflows, improve collaboration, and ensure that the development process is efficient and effective. However, these are not the only tools that backend developers use to manage workflows. Using version control systems and continuous integration, continuous deployment, or CI/CD pipelines also help backend developers manage their work efficiently. Version control systems allow multiple developers to work on the same project without causing conflicts by tracking changes to the code. They keep a clear record of all changes, making it easier to collaborate, review code, and undo changes if needed. CI/CD pipelines automate the process of testing, integrating, and deploying code changes. This means that new code can be continuously checked and delivered without manual effort, reducing the chances of errors and speeding up the release process. Tools like Jenkins, CircleCI, and GitLab CI are popular for setting up these pipelines. By using project management tools, version control systems, and CI/CD pipelines together, backend developers can keep their work organized, collaborative, and efficient. This combined approach not only boosts productivity, but also ensures the development process stays smooth and aligned with project goals. In this video, we discussed how to manage workflows using the Agile methodology, version control systems, and CI/CD pipelines effectively. We also covered the key concepts of Agile, including the role of ceremonies and artifacts. Using the Agile methodology can help streamline development processes, including collaboration, and lead to successful project execution. Development teams optimize their workflows to deliver high-quality products quickly and efficiently. In this video, you will explore best practices for managing workflows in backend development. The processes that a backend development team uses to manage their work, such as Agile, help each member coordinate their work. There are also practices and tools that help them automate their work, share it with each other, and provide a backstop in case their work gets corrupted, lost, or complicated issues arise. Let's begin our exploration of optimizing backend development by investigating the practice of version control and version control systems. Version control is the practice of managing and tracking changes to software code or documents. Version control is essential in modern technical projects, often involving hundreds of individuals working on different parts of the system. It allows everyone to work simultaneously while ensuring the development of a complete functional product. Now let's examine the tools that make this practice possible. Version control systems. Version control systems are software tools that record changes to a file or set of files over time so that you can recall specific versions later. This allows multiple users to track revisions and collaborate effectively. With a version control system like Git, teams can store all the code, images, video, and other project files in one place. It allows the team to track code changes and daily work, revert to previous versions of their code, and share their code with other members of the team without overriding each other's work. Imagine you're on a development team working on the back end of a social media site. Each developer is assigned different parts of the back end. One is handling user authentication, another is setting up databases, and another is fixing bugs. Using Git, they can all work simultaneously on their respective parts. Meanwhile, they can see each other's changes and collaborate seamlessly, ensuring the entire project stays in sync. If something goes wrong, the team can use Git to revert to a previous version without impacting the other's work. Version control systems use a technology called branching, which is similar to making a photocopy of a document. The main code acts as the original document, and when a new branch is created, it's like a copy that has been made that developers can mark up and edit freely. Developers can add to, modify, and test this copy without impacting the original. Once they're sure their edits are correct and stable, they can merge these changes back into the main document, updating it with the new modifications. Imagine that on a branch, one of you makes a small change to fix a bug that impacts the timestamp when a user posts an update to their social media profile. However, after merging the changes, users' updates suddenly stop saving altogether. The team tracks down this specific issue and the specific branch and reverts to the previous stable version. Without a version control system, this would be extremely difficult. Now that we understand the importance of version control, let's explore how we can further optimize our development process using automation. Continuous integration, or continuous deployment, also known as CI/CD, builds on the principles of version control by ensuring that every change is seamlessly tested and deployed. CI/CD takes workflow management to the next level, starting with source control integration. Source control integration is the process of combining code changes from multiple developers into a shared project repository, ensuring that these changes work together correctly. Integration involves merging code from different branches into the central repository, ensuring that all changes are incorporated. It also involves running tests to verify that the code works as expected. Finally, it involves building the program. A build is the process of transforming source code into an independent program that is ready to be deployed on a server. Once code from all developers is integrated, tested, and built, it's ready to be deployed for users. Deployment is the process of combining code changes from multiple developers into a shared project repository, ensuring that these changes work together correctly. Deployment means getting your code ready to go live. This includes setting up servers and databases, deploying the code from deployment to production, and monitoring the program to make sure everything runs smoothly after launch. So how do we go from integration and deployment to continuous integration and deployment? Step back to the early 1900s, when building a car was a manual and slow process, with each worker responsible for a single part of the assembly. This method was prone to errors due to human fatigue and made cars a costly luxury. Then, a pivotal change occurred with the introduction of the first moving assembly line for automobile mass production. This innovation dramatically cut the time needed to assemble a car, making it more affordable and accessible. Similarly, the software development process used to be highly manual and involved many people with specialized skills. From integrating, testing, to deployment, everything was manual. Today, CI/CD pipelines and tools automate parts of the software development process in a similar manner to the automation in car manufacturing. CI/CD pipelines automate the integration and deployment of code, ensuring that new changes are quickly and reliably delivered to users. CI/CD aims to speed up and improve the development process by catching issues early and ensuring that your codebase is always deployable. By combining the strengths of version control with the power of CI/CD, development teams create an environment where changes are managed, tested, and deployed quickly. This approach ensures that your workflow remains efficient and allows you to respond rapidly to a changing digital environment. In this video, you learned the basics of optimizing backend development processes by implementing effective version control strategies and automating integration and development processes using CI/CD. In this video, you learned the basics of optimizing backend development processes by implementing effective version control strategies and automating integration and deployment processes using CI/CD. A beautiful symphony is composed of many intricate elements. Musicians with their instruments ready to play, sheet music that guides each note they produce, and a conductor who ensures everything is in perfect harmony. Backend development projects are like a symphony. Developers craft the code, the music of the software world, using their tools. Project planning tools are like sheet music, outlining what needs to be built and when. At the center, integration acts like the conductor, ensuring that the proper development tools and project planning tools work together. In this video, we'll explain how to integrate project planning tools with development workflows. Integration is the process of combining or coordinating different tools or systems so they communicate and work together. When project planning tools are integrated with development workflows, project management and execution align more closely, leading to more effective and efficient projects. Let's explore the specific tools that developers rely on and examine how integrating these tools, starting with project planning tools, can streamline processes and improve collaboration. Project planning tools such as Jira, Trello, and Asana are software applications that help manage tasks, track progress, and facilitate collaboration within development teams. These tools provide a structured way to manage tasks, enable team communications and collaboration, and track progress and deadlines. You can integrate these project planning tools with development tools to create a seamless workflow. One key development tool is the Integrated Development Environment, or IDE. An integrated development environment is the primary tool a developer uses to write, test, and debug their code. It combines essential tools such as a code editor, compiler, interpreter, and debugging tools in a single interface. Some popular IDEs include Visual Studio Code, Eclipse, and Xcode. Suppose a team uses Jira for project management alongside Visual Studio Code for development. By integrating Jira with Visual Studio Code, a developer can manage the tasks directly within the IDE. This integration not only simplifies task management by keeping it within the development environment, but also ensures that updates are synchronized across both platforms. Another integral part of the developer's workflow that can be integrated with project planning tools are version control systems. Version control systems are tools that track and manage changes to code over time, allowing multiple developers to collaborate on the same project without overriding one another's work. Integrating project management tools like Jira, Trello, and Asana with version control systems like GitHub links project tasks to code changes. For example, committing code to GitHub can automatically update the related task status in Jira. This synchronization ensures all team members stay informed of the latest developments and can track progress in real time. With a clear understanding of the key project planning tools and development tools, we can now turn our attention to the practical steps of integrating these tools within development workflows. While individual tools differ in specific integration steps, they generally follow the same basic steps. First, define the workflow. Outline key development stages, planning, development, testing, and deployment, and decide which stages would benefit most from integration, such as linking tasks to code commits or updating task statuses based on code reviews. Next, it's time to set up the integration. This step will be different depending on the tools you use. However, there are three common ways to integrate tools: native integrations, middleware tools, and custom APIs. Many tools come with native integrations, which are built-in connections provided by software platforms that let users link with other applications directly without the need for additional coding or third-party software. Developers can also use middleware tools to integrate tools. Middleware tools are third-party tools that act as a bridge between different software applications, facilitating communications and data management between systems that may not have direct integration capabilities. Some examples of middleware tools might be Microsoft BizTalk, Flow middleware platforms, or IBM WebSphere. In addition to native integrations and middleware tools, developers can also choose to develop and use custom APIs for integrations. This approach involves creating tailored connections using an API to link different software systems in a specific way, often requiring custom coding, but offering the highest level of customization. The final step of integration is to set up the automations. Set up the integration automations so actions in the development tools like commits, pull requests, or successful builds automatically update tasks in the project planning tool. Once the integration is complete, it offers many benefits, including enhanced productivity, better project tracking, and improved collaboration. Integration reduces the need for manual updates and data entry, enhancing overall productivity. This allows developers to focus more on coding rather than administrative tasks, thus speeding up the development process. Also, tracking project progress becomes easier with integrated tools, providing a comprehensive view of the project status. And integrated tools provide team collaboration, allowing them to share updates and feedback in real time. In this video, we discussed integrating project planning tools with development workflows and tools. Integrating these tools ensures seamless transitions between planning and coding, making project management more efficient and effective. Imagine you're navigating through a complex city without a GPS, only a paper map. Each time you reach a new intersection, you have to stop, unfold the map, and figure out your next move, all while hoping you haven't taken a wrong turn. Now, think of a project being managed in a similar way. Each step of the development process requires manual updates, constant back and forth with the project manager, and an outdated task list that only one person controls. Without integrated tools to guide you in real time, your development project will become just as cumbersome and prone to delays as navigating that city was without a GPS. In this video, we will describe the advantages of integrating project planning with development tools. Integrating project planning tools like Jira, Asana, and Trello with development tools such as integrated development environments, also known as IDEs, and version control systems provides multiple benefits for back-end development projects. Teams that use these integrations experience enhanced productivity and better project tracking, improved collaboration, and increased alignment between planning and execution. Let's begin by exploring how integration can enhance productivity. Integration reduces the need for manual updates and data entry, enhancing overall productivity. This allows developers to focus more on coding rather than administrative tasks, thus speeding up the development process. It can automate certain processes. For example, when you commit code for a new API feature to a version control system like GitHub, an integration can automatically trigger the start of automated tests in a continuous integration tool. Integrations also help manage individual tasks without human intervention. For instance, when you commit code for the new API feature, the integration automatically updates the task status in your project management tool, saving you time and effort. When the integration between the IDE and the project planning tool automatically updates the status of your tasks, it also minimizes context switching. Context switching refers to shifting your attention from one task or system to another, which can disrupt focus and reduce productivity due to the mental efforts required to reorient to each new task. The automation allows you to stay within your IDE to continue working, testing, and committing code. This increased productivity enables you and your team to accomplish more in less time, resulting in faster project completion and more efficient resource use. Additionally, integrated tools ensure better project progress tracking. When project management tools are integrated with development tools, project progress tracking becomes automated and instantaneous. For example, when you mark tasks as complete directly from your IDE, the project management tool automatically updates the progress. This integration removes the need for manual entry, ensuring that the project status always reflects the latest developments without any delay. The project manager and others on the team know exactly what the task status is at any given time. This real-time project tracking can allow for quick adjustments and informed decision-making, ensuring that the project stays on track and within scope. Integrated tools also improve team collaboration. When working with your team, integration between tools means that whether you are writing code, the project manager is updating project plans, or a marketing team member is reviewing timelines, you are all accessing the same tools and information. These tools also often come with integrated communication features. This integration ensures that the communication about specific issues or updates is immediate, clear, and always linked to the relevant project context. These tools also improve collaboration with their many shared documentation features. Finally, integration enables teams to have increased alignment between project planning and project execution. Closely integrating the development work with the project plan helps ensure that the development work aligns with the project's goals. It also allows teams to adjust the plan as the project progresses and provides a continuous feedback loop between the planning teams and the execution teams. Better alignment between planning and execution ensures that the project remains focused on its goals, reduces the risk of scope creep, and improves the chances of success. In this video, we cover the advantages of integrating project planning with development tools, including improved collaboration, enhanced productivity, real-time tracking, and better alignment between planning and execution. Implementing these integrations ensures that your development processes are streamlined and effective, leading to successful project outcomes. Imagine you're a chef in a bustling kitchen, working with a team to perfect a complex recipe. Each of you contributes your unique techniques, adjusting ingredients and testing different approaches. But what if at any moment you could not only see who added what, but also have multiple chefs experiment with variations simultaneously without affecting the original dish. That's exactly what Git allows you to do in backend development. Track changes, collaborate in real time, and experiment with new ideas, all while preserving the integrity of your codebase. In this video, we will describe the basic Git commands and their uses in backend development. Version control is crucial because it tracks all changes made to the code, allows multiple developers to collaborate simultaneously, enables easy reversions to previous versions, and lets developers work on new features or fixes without affecting the main codebase. Though there are other version control systems, most developers use Git for version control. Git is a distributed version control system that helps developers track changes, collaborate, and maintain the history of their code. Think of Git as the essential kitchen tools every chef needs, like knives and cutting boards, which help them create and manage versions of their culinary creations. GitHub, on the other hand, is like the central kitchen where all chefs store their recipes and tools, showcase their dishes, and collaborate with other culinary experts. So how does Git enable developers to maintain the history of their code, track changes, and collaborate? Git involves the use of repositories and branching. In Git, a repository is a storage space where all files related to a project are kept, including their complete change history. These repositories hold snapshots of all versions of the code, allowing developers to track changes, maintain history, and roll back to a previous version if necessary. Next, let's explore branching. If you think of the main code as the main branch, developers create other branches when they need to add new code or make changes to the existing code. Think of branching like making a copy of a folder. And when a new branch is created, it's like making a copy. Developers can add to, modify, and test the documents in this copy without impacting the original. Once they're sure the edits are correct and stable, they can merge the changes in the folder back into the main branch, updating it with all the new modifications. Developers use repositories and branching to manage their code with the help of Git and GitHub. But how do developers interact with these tools? They execute commands. Developers execute commands from the command line or through an application like GitHub. These commands include clone, branch, commit, push, and pull. Let's explore each of these commands in detail, starting with clone. The clone command creates a local copy of the repository a developer is working on. This allows them to start working with the codebase on their own machine. To use the clone command, you would type git space clone space, then the URL of the repository. For instance, if you're developing a new feature for user authentication, you would first clone the existing project to your machine. Once you have a local copy of the repository with the clone command, the next step is to create a new branch. Branching allows you to work on specific features or fixes without affecting the main codebase, keeping your changes isolated until they're ready to be merged. For example, to create a new branch for your feature, you would type git space branch space followed by the branch name. For your user authentication feature, you might create a branch by using the command git branch feature-authentication. Now, you're ready to get started on the development work. Once you write some code or make some changes to the existing code, you will commit your code. The commit command captures a snapshot of the changes in a project. This allows you to track your progress and revert to a previous version if needed. To use the commit command, you would type git space commit space -m, then a commit message in quotes. Notice that commit commands include a commit message. This is where developers write a meaningful message to describe what changes were made to the codebase. For example, after creating the basic structure for a registration form, you might commit with a message, initialize user registration form. When you're done with all of the changes, you can use the push command. The push command updates the remote repository with local changes, allowing others to see and use those updates. To use the push command, you would type git space push space, then the name of the remote repository, and finally, the branch name. Once you're satisfied with the development and testing of your new user registration feature, the next step is to share your work by pushing it to GitHub. Just type git push origin feature authentication to upload all your commits from the feature authentication branch. The next day, you're ready to start working on the next feature, so you execute a pull command. The pull command updates your local codebase with the latest changes from the remote repository, ensuring you have the most current version. To use the pull command, you would type git space pull space, then the name of the remote repository, and finally, the branch name. You use the pull command git pull origin feature authentication to pull down the latest version of the code in the repository. After pulling the latest updates, you can go back and use the branch command to create a new branch from the updated main branch to start working on your next feature. This workflow maintains the integrity and continuity of the project, allowing all developers to work collaboratively and efficiently. Today, we covered the basic Git commands and their uses in backend development, including clone, branch, commit, push, and pull. Understanding these commands is essential for tracking changes, collaborating with team members, and maintaining a reliable code history. Integrating Git into your development workflow will significantly enhance your efficiency and productivity. Imagine stepping into a team tasked with developing a cutting-edge telemedicine application. You're responsible for bringing to life features like virtual consultations, patient record management, and appointment scheduling. Together, you'll transform innovative ideas into a fully functional platform that could revolutionize healthcare. To keep everyone on the same page, your team relies on GitHub, a powerful version control system that allows for seamless collaboration, change tracking, and efficient peer reviews. In this video, we will explain how to use GitHub for collaborative backend development. GitHub is more than just a place to store code. It enables collaboration through the lifecycle of a project, making sure that everyone's contributions fit together seamlessly. Instead of developers working in isolation and trying to merge their work at the end, a process prone to conflict and errors. GitHub allows developers to continuously observe how their contributions fit with the team's work, ensuring seamless integration. It also allows them to share resources such as common libraries, tools, and code snippets to increase efficiency and consistency across the project and follow clear workflows for coding, reviewing, testing, and building. Now that we've covered why GitHub is such a powerful tool for collaboration, let's explore the specifics of how developers can actually use it to work together effectively. You can both collaborate and manage projects by using GitHub to create a repository, manage branches, submit pull requests, and conduct code reviews. So where does your project start? It all begins with creating a repository, the home base for all your code and collaboration. Creating a repository involves logging into GitHub, navigating to the repositories section, and clicking the New button. You will need to provide a name for your repository, an optional description, and choose whether it will be public or private. For example, you might start a new project by creating a repository named Telemedicine App on GitHub, making it private to protect sensitive patient data. With a repository in place, your team is now ready to start developing. But how do you make sure that multiple people can work on different parts of the project without overwriting each other's code? This is where managing branches comes in. To create a branch, navigate to your repository on GitHub and use the Branch drop-down menu to create a new branch. Naming conventions often include the feature or fix being worked on. For your telemedicine application, you might create a branch for the new feature, virtual consultations, to ensure the main branch remains stable and production ready. Now that you've made progress on your branch, it's time to merge your changes back into the main project. To do this smoothly and with oversight, you'll submit a pull request. After committing changes to a branch, navigate to the Pull Request tab in your repository and click New Pull Request. You can then compare changes across the two branches and provide a description of the proposed changes. For instance, you submit a pull request to merge your virtual consultations branch into the main branch, describing the new virtual consultation functionality you've implemented. Finally, it's time to have a colleague review your work. You initiate a code review that involves a team member reviewing changes proposed in a new pull request to ensure code quality and functionality before merging. Reviewing a pull request involves checking the code for errors, adherence to coding standards, and overall functionality. Reviewers can comment on specific lines, suggest changes, and approve the pull request once satisfied. Your team members review your virtual consultations pull request, while you get a code review request from another team member working on the patient record management feature. You notice that the code lacks encryption for sensitive patient data, so you add this as a comment in your review. This code review helps maintain high-quality code and ensures the application complies with data protection standards. In this video, we explained how to use GitHub for collaborative backend development, including creating repositories, managing branches, submitting pull requests, and conducting code reviews. By setting up and using GitHub repositories, development teams can effectively collaborate, manage code changes, and maintain a high-quality code base. This enhances productivity and ensures successful project outcomes. Understanding the fundamentals of backend development is crucial for any software engineer. It lays the groundwork for creating efficient, robust applications that can seamlessly handle complex data and user interactions. We begin by defining backend development and its vital role in driving application functionality. We explored the core principles that ensure efficient, dynamic backend solutions. We explored the roles and responsibilities of a backend engineer, understanding the key skills and technologies they used. We examined the workflow and scope of backend engineering to see how these professionals support the core functionality of modern applications. We then covered the fundamental steps for planning a backend project, focusing on strategies for effectively organizing resources and maintaining clear documentation to guarantee a smooth execution. Next, we identified the essential tasks in backend development and examined strategies for managing workflows to achieve efficient and streamlined execution. Then we examined ways to seamlessly integrate project planning with development tools, optimizing workflows and enhancing the efficiency of backend development processes. Finally, we examined the basics of Git and GitHub, examining their importance for version control and enabling effective collaboration in backend development. A firm grasp of backend development empowers you to create robust applications that drive functionality behind the scenes. By integrating thoughtful planning, efficient workflows, and collaborative tools, you lay the groundwork for scalable and impactful software solutions.